When I first started working here in the early 90s, this is where the glacier was. I mean, where we're walking right now would have been a pile of gravel that had been pushed up by the glacier, and then we would have had 100 to 200 foot high cliffs of ice right here. And as you can see, that's changed quite a bit. And if you look at that in 2 dimensions, you can sort of see the terminus used to be here, now it's back there. That gives you one measure. What that kind of 2-dimensional look doesn't show is how much mass has been lost, that the glacier has just sort of deflated. These 200-foot cliffs of ice have disappeared and pulled back to this gentle sloping glacier you see now.
When I was working in Kenai Fjords National Park, I used the topographic maps to navigate where I was, and I realized that the mapping of the glaciers was really off. The glaciers had receded a lot. There were new rivers and lakes that were establishing where the ice used to be or should have been according to the maps. And so then I did a study on this and found out that we had a 5% loss of glacier ice mass in the Kenai Fjords area between 1950 and 1985. Big change.
You know, one of the most compelling things we do, though, to document glacier change is simply take photographs. We've had repeat photography projects here at the park. They may not give you the most accurate data in terms of how much mass or real specific measurements, but what they do give you is a visual representation that can't be argued with. I mean, it really requires no interpretation.
Understanding what's happening, understanding these processes, and possibly being able to predict what's going to happen in the future is the best that we can do, and that requires science and research.
There's considerable research on climate change in Alaska. The most significant, I would say right now, is the Natural Resources Inventory and Monitoring Program, which is looking at change across a wide variety of vital signs or indicators.
Kenai Fjords National Park is actually a pretty good representation of what's going on globally with regards to glacier ice retreat. There have been studies showing that mountain glaciers are retreating all over the planet. There are probably well over 90% of the glaciers are in retreat status. There are a few that are advancing, and some are holding their terminus point. But at Kenai Fjords, the tidewater glaciers are retreating more dramatically, but even the land-based glaciers in the terminus positions are retreating. It's pretty common for all the mountain glaciers. The big mountain glaciers in Wrangell St. Elias National Park, they're mostly in retreat too. We're really entering an interesting phase where what we call the cryosphere, the ice on the planet, is melting.
You know, in the more immediate past, it's clear that since the Pleistocene, glaciers have been retreating. So the idea that glaciers retreat is no revelation. They've been retreating from across North America for the last 10,000 years. What appears to have changed and what has people's attention is the rate at which they're retreating. In the case of Exit Glacier, you know, we have scientists who've been looking at it. We have evidence that the glaciers left behind, or we can track that retreat for about the last 200 years. And we can say with confidence that in the last decade, that rate has increased.
Terminus mapping is a great way to map a small portion of the ice field. We come out twice a year and we use a GPS to walk the edge of the terminus and map the farthest extent of Exit Glacier. And that allows us to see what type of changes are occurring over the winter accumulation period and the summer ablation period. With that data, that can help us as we witness these changes within the ice field, we can hopefully be able to correlate that with the weather data that we have.
You know, when you look at an ice field that's 750 square miles, when you look at a glacier that towers hundreds of feet high, you get a sense of permanence. You think these things are massive, they're somehow a permanent sort of feature, and yet in a very short period of time, in a matter of a couple of decades, we've seen dramatic change in those things.
At Exit Glacier, we have a time-lapse camera set up on the glacier that allows us to take a couple photos every single day, and then to put that sequence of photos into a video where we can see changes of the glacier and the vegetation phenology throughout an entire year.
Virtually all the glaciers in Alaska are receding. Some glaciers are moving forward. That's not an indication that they're actually growing in size. It's just the rate at which they're slipping down the mountain.
In some cases, some of these glaciers are receding back up onto land, and so they're producing less ice. When you change the glacier systems, you're changing habitat for marine mammals and other wildlife. And the populations of harbor seals have dropped dramatically in the fjords. In 1980, shortly after the establishment of the park, in Isleck Bay, we had maybe 1,500 harbor seals. Nowadays, it's a few hundred.
In Arctic environments, much of the sunlight that reaches the Earth bounces back because it hits snow and reflects off into space, or ice on the ocean and reflects off into space. That's the albedo effect. When the snow thaws and instead you have rock or vegetation, or when the ice thaws and you have transparent ocean, the sunlight will convert to other wavelengths. It'll convert essentially to warmth. That does not bounce back into the atmosphere as much. So consequently, you get a warming of the ocean, you get a warming of the ground, you get a thawing of frozen soils or permafrost, you get a more rapid thawing of sea ice. So once the ice and once the snow is off of the surface, the rate of warming increases considerably.
If you're driving out to Exit Glacier, you'll actually start to see signs along the side of the road that have dates on them. Visitors sometimes are confused. They think they're elevations or something until they get up to the glacier and realize, oh, those were all date signs along the road that were telling me when the glacier was there. Another thing that's been happening in the Exit Glacier area in recent years is this flooding that comes at a time we're not used to. We're used to having maybe some flooding in the fall when we have a lot of heavy rain. This has suddenly been some flooding that's coming in the middle of the summer, usually not associated with precipitation events. It's associated with warmer weather and melting. When you walk down one of our trails that leads to Exit Glacier, there are a number of ways to get out there, but what used to be the main route is no longer really the main route because of the way the glacier has changed. So this main route to the glacier used to provide dramatic views of the glacier as you walk towards it. In fact, there was a large kiosk built at the end of this trail for people to stop and rest and enjoy the view of the glacier. Now, if they stop and rest at this kiosk, people think, why did the park put a kiosk here? Because it looks out at some shrubs. And there's no glacier within view anymore.
The way we solve big problems like this is not all at once. There's a thing called the Sokolov's wedges, and you just take a little bite of the pie, one sliver at a time. So we try to do incremental changes.
When we talk to people about our concerns about climate change, about the changes that are happening to the glacier, we also want to leave them with some idea of what we're doing to mitigate some of the effects of climate change. For example, here at the park, as we retire vehicles out of our fleet, we try to replace them with electric vehicles or hybrid vehicles. We've done things like at the Exit Glacier Nature Center, helping to sort of experiment and install a cutting-edge fuel cell as opposed to running some traditional power source out there that relies on some sort of more greenhouse-producing gas.
My main hope for the future is that people get the message that the planet is changing fairly rapidly in places, particularly places like Kenai Fjords National Park, and that it is, we think, there's good evidence it's a result of atmospheric changes, which are measured in terms of human inputs into the atmosphere.
The rapid rate at which these glaciers are changing now offers us the opportunity to talk about this place as a way of looking into the future. In a lot of parts of the country, climate change issues are a little more subtle. And we can point here and say, look how fast this is changing. This is what the future holds for perhaps a lot of us and a lot of the planet as climate continues to change.
I'm optimistic that people and nature will adapt to change, but my expectation is that change will occur. Time will tell.